Graph database is implemented by means of Neo4j. Let us try to understand what is the meaning of Neo4j and what language will be used for implementing graph database. Neo4j is one of the popular graph databases and it uses a language called as cipher query language for the construction of graph databases. Neo4j is actually written in Java language. A graph structure, as discussed earlier, will be having nodes and edges, or we can call it as vertices and edges. Nodes represents the data, and the connectivity is represented as relationship. What is the advantage of using Neo4j? It's a flexible data model. Any changes can be done very easily by means of Neo4j. It also retrieves real-time insights. The failure of a single node will not be there since the data will be saved in a distributed environment. It can also have both semi-structured as well as structured data also can also be saved. The only disadvantage is the content should be less. Since the content is less for each nodes, the retrieval process becomes easy, that too especially by using Neo4j and its associated language. As I mentioned earlier, cipher query language is the only language that the Neo4j understands. It's a declarative query language. Since the biggest disadvantage of relational database is joins. So in graph-oriented databases, there is no need for you to apply joins since the content of each node is less and they have a relationship and the language that is being used, the cipher query language, automatically retrieves the information connected to it. And hence, joins are not required. So we'll try to quickly go through some basic representation of cipher query language and how okay it is okay, how exactly the graph database is been implemented. As I mentioned, it's a query language which implements graph database. It's a declarative pattern matching language. It's something similar to your SQL syntax, but it's not exactly equivalent. It's very simple and you can read it also. It's a human readable format. So let us try to understand how to create okay some relationship. Let us assume that Anita, Rahul, Sneha and Vikram are friends. Let us understand how to create the nodes and create relationship by means of friend. So this is the end resultant that I want. Okay, what you can observe is uh, Anita, Rahul, Vikram, and Sneha are friends. So we have represented in the form of a graph. So what does it mean? Okay, it means okay, Anita, okay, friend is Rahul. So this is bidirectional. If you understand the meaning of bidirectional, if I say another Anita is friend of Rahul, it also means that Rahul is a friend of Anita. In this case, we'll try to implement it. Okay, so explicitly. Similarly, I've connected Anita with Sneha. So Anita is a friend of Sneha, and Sneha is a friend of Anita. Similarly, Vikram is a friend of Rahul, and Vikram is also friend of Sneha. So vice versa is also applicable. So how do we create this kind of representation? So let us understand how we try to do it. So I use syntax. The syntax is very simple. We use something called as create. Uh, Anita is the name of the person and the name is Anita. So we are giving the name node as Anita And I've also tagging the name for it so that it can be used in further representation. I repeat. So this is the name of the node and this is the field name. So field name is different. The node name is different. Right now, just imagine that Anita, I've taglined as person and I can indicate multiple fields. So you can say a name Anita. You can say age, okay, comma, age is 31, something like that. Okay, so that can also be included. So this becomes the core component. So Anita person is the core component. This is the label, name of the label, and this is its property. So indirectly, all these are persons. Anita is a person. Rahul is a person. Vikram is a person. Sneha is also a person. That's what it means. Within that, I have said I am saving Anita as the name field, key value pair. So it is saved in a key value representation. It is saved in a key value representation. So similarly, I'll create Rahul. So we have created A, R. A represents Anita, R represents Rahul. So Rahul is person. Within that, I have a key value pair. Name is a okay, name field. Name is the key. Rahul is the value. Sneha is being created. So we also create Vikram. So we have created four persons. Anita, Rahul, Sneha, and Vikram. So I'll create mutual friends. So I'll use this is also create. I use create. So Anita is already being created. So this is okay what we are representing. I'm saying friend. Okay, so hyphen, okay, friend. This becomes the relationship. This becomes the relationship. Okay, so I can similarly, because I said both the sides I should create, both the sides I should create. Okay, so I'll be creating, okay, similarly for Anita also. Anita with Sneha is being created. Similarly, Rahul with, okay, Rahul is connected with Vikram. Rahul is also connected with Anita. So I'll try to indicate that also. Okay. Sneha is connected to Vikram. And okay, so I've connected. So I've represented this particular diagram, whatever that I've written. So this, okay, graph is being created. So we've created the graph. So once we create the graph, so in this case, what we have created, this actually created the nodes. So this actually creates the node. This actually creates the nodes. This is how the relationship is created. So relationship, in this case, the relationship is friend. Relationship is friend. So we've created a very simple representation. Now let us try to understand how to use the queries. Okay, let us try to understand how to use queries. So the first query that I'll say is, so this is a match is a functionality of your Neo4j when okay, of course it is using CQL. Uh, Match is an inbuilt function. The first parameters are the parameters that are used are okay. First is what kind of person it is. So I'm saying Anita is the person. Try to find out the friend, and I will be saving the resultant as friend. That's it. So retrieve friends of Anita. So Anita is directly connected with what? Rahul. Anita is connected with Sneha. So these are the two friends. Two friends. Okay. So the end resultant of this, okay, will return. So this actually, in the first instance, it actually, okay, creates and the end resultant is saved in friend. From there, I am retrieving what? The name fields because this will give you me all the nodes from the node, what do you want? Okay, you want okay the name, a key value pair. Okay, so the key that is name. So retrieve all of them, and once again I'm using a renaming operator, and the resultant will be saved as friend name. Resultant will be saved as friend name. So the okay, so you can observe the resultant. This is the resultant that you get. So match is a functionality. It is as I indicated, it's a declarative language. Uh, we also indicate okay what we want, and accordingly their values are retrieved. So let us try to understand one more. Okay, finding out okay mutual friends of Rahul and Sneha. So you can just observe. Okay, if you observe the diagram, Rahul is connected with Anita and Okay, sorry, Rahul is connected with Anita and Vikram. Similarly, okay, Sneha is also connected with Anita and Vikram, right? So this is the connectivity. This is the connectivity. So they have been connected. So if that is the case, how do I do it? Okay, so I use once again the match functionality, friend. So the mutual is the keyword once again, the mutual friends. Okay, mutual friends of Rahul and Sneha. Okay, to be retrieved. So match is the function. So I use a return distinct. Okay, so mutual dot name is okay how you represent. So I want to save it in the resultant as mutual friend. So this is how it looks like. So return is a function. Okay, return distinct. If you understand, it retrieves distinct values. Okay, if there's a repetition, repetition will be removed. So this is how okay the representation of Neo4j looks like.